Let's look at section 8.1, which is on the conic section, parabola. So we've learned about parabolas before, but this is going to be from a different perspective. To begin with, let's look at this definition. A parabola is the set of all points that are equidistant from a point called the focus and a line called the directrix. So there is a link on Canvas right here, GeoGebra definition of a parabola. I want you to click on that. And what it shows is essentially this definition. We can get rid of that. We have a line called the directrix. You can see it can move. You have a point called the focus, which you can pick up and move. And GeoGebra created the parabola based on this focus in the directrix, such that every point that's on the parabola, like this point C, is equidistant from the focus and the directrix. When we measure the distance from a point to a line like a directrix, it does need to be perpendicular, which is the shortest distance. So you could see as I move around the point, I'm getting closer, but the distances are the same. And at one point I'm going to get to the vertex, and it looks like it's about 5.7. This is a value called P that we're going to use, or the absolute value of P, because P can be negative, but we still think of the distance as positive. And then we go around. So go ahead and play with this, see how it works, move the focus around. What happens when you move the focus there? What happens when you move the line? Well, this is just the measure of the angle. We can move that back. You can see how it changes. What happens when the focus and the directrix get closer and closer and closer together? You'll notice the parabola is getting narrower. When they're further apart, the parabola gets wider. Okay, so let's look at how we graph them. Now, in this particular case, we're thinking of it geometrically, so it's kind of all over the place. We're not going to do diagonal parabolas in the coordinate plane. Right? Somewhere there's a coordinate plane. We're not going to graph them like this. We're only going to do 4 cases: up, down, left, and right. So to begin with, we're going to look at the ones that are up and down, which have a vertical axis of symmetry. So here's our equation. X minus h, quantity squared, is equal to 4 times p times y minus k. So you notice there's a lot of formulas here that use h, k, and p that we're going to see. All right, to begin with, how do we determine if it's up or down? Well, before we had an a value, this is essentially what used to be called a. So if the a was negative, we'd open down. If it was positive, we'd open up. This time we're going to think of it as p. So if p is positive, it's going to open up. If p is negative, it's going to open down, using that p value. The vertex is hk. The p, as I showed you, is, or the absolute value of p, is the distance from the vertex of the parabola. Remember, the vertex is this point. And so it's the distance from the vertex to the focus, which is inside, and the directrix. Let's try that again so we can actually read that. D-I-R-E-E-C-T-R-I-X, which is out here. So you don't necessarily need all of these formulas, but they come in handy if you want to use them. Let's do some very simple examples. And so both of the examples that I'm going to do are going to have an h and k of 0 to begin with, so we can focus on the p. So if h and k are 0, your equation would be x squared equals 4p times y. So that would mean you are at the origin. So 0, 0. Okay, So I'm going to do one that opens up and one that opens down. So our first example, example 1, is going to open up. So I'm going to make it positive. So let's do x squared is equal to 8y. Okay, so I already know that h is 0. I know that k is 0. But what about p? So when I'm looking for p, I'm looking at this number that's in front of the y. That is 4 times p. So I have to divide that by 4, and I get that p is 2. So since h and k are 0, 0, we're going to put our vertex at the origin. Since this is positive, it's greater than 0, we're going to open up. So the next thing I'm going to do is put my focus. The focus is always inside of the parabola, and so I'm going to use this 2, the absolute value of which is 2, and I'm going to go up 2. So this is where my focus is going to be, and that is at the point 0, 2. My directrix is going to be 2 in the opposite direction, so if I go down 2, I'm going to get a horizontal line, and there's my directrix. And the equation of this line is y equals -2. So if I were to plug in a, h, and k into these equations that we have here for the focus and the directrix, they would work. Okay, the next thing I'm going to need is to graph the parabola. And the way that I do it is I use something called the focal width. The focal width is a distance across the parabola at the focus. So or the width at the focus. So 4p. So that's usually just going to be the absolute value of that number right there, which is 8. So at this focus here, the width of the parabola is going to be 8. So what I do is I cut it in half. So I think 4 and 4. And I go left and right 4 from the focus. And at the end of that, you can put some points. And then that is how we're going to graph the parabola very quickly. Make that a little nicer. Okay. There we have it. So this distance is the absolute value of p. This distance is the absolute value of 4p. So this is the focal width. The focal length is just the p, the absolute value of p. Should be an absolute value. All right, let's try when that opens to the opens down. So in this case, it's going to be negative. So example 2, x squared is equal to -10y. Okay, so 0, 0 again for h and k. Vertex is at the origin, but what's p? So in this case, I would take -10 divided by 4. That's going to give you -2.5 or -5/2. I don't usually care for decimals, but in this case I need to estimate on a graph, so I will write it as a decimal. So since it's going to open down, my focus is going to go downward 2.5, about there. My directrix is going to go upward 2.5, so about here. Okay, my focal width is the absolute value of a -10 or 10. And that's going to be the width of the parabola at the focus, which is right here. So I'm going to go left and right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I can connect my vertex to those points. And there's my parabola. All right. So now we're going to do parabolas that open in a different direction, and there's a typo here. It says the equation of a parabola with a vertical axis. No. Change it to horizontal. So now we're going to do horizontal axis of symmetry, which means we're going to open left and right. Okay, so to begin with, let's pay attention to the equation. H is over here. K is over here. If you remember that X kind of goes with H and Y kind of goes with K, it's going to be helpful. And then P we have here. It's going to open to the right if P is positive, and open to the left if negative. And P is still going to be the distance from the vertex to the focus and the directrix. Okay, first example we're going to do is one that opens to the, let's say, to the right. So if it's going to open to the right, then we're going to have a positive. And again, we're going to keep our vertex at the origin. So it'll be, let's do y squared is equal to 12x. So again, h and k are 0, 0. Our p is 12 divided by 4, which is 3. And since it is positive, we are going to open to the right. So that tells me that my focus is 3 units to the right of my vertex. My directrix is 3 units to the left. Okay, so our directrix now is vertical. And we write a vertical line x equals, in this case, x equals -3. So this is our directrix. This is our focus. And our vertex. Then we have our focal width. Our focal width is 12. So we're going to go up and down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this distance here is our focal width. And then we can graph the parabolas through those points. Here we go. So let's do one now that opens to the left. So we're going to have y squared is equal to, and we need a negative, so how about -4x? So h and k are 0, 0, and p would be -1. So we're going to open to the left, and our focus is going to be 1 unit to the left, and our directrix is going to be 1 unit to the right on the outside. Okay, so our directrix is the equation x equals 1, and then our vertex is -1, 0. Focus, sorry. Our focal width is 4, so which is the absolute value of -4. Cut it in half. So the whole thing is 4, but we go 2 in each direction, and there she is. Okay. The axis of symmetries for these are going to be horizontal. Horizontal. All right, so now we're going to look at a couple examples with h and k, and then we're going to look at a couple examples of finding the equation. Okay, so the thing about h and k is we want to pay attention to where the x is. H will be nearby. And where the k is, the y is, the k will be nearby. So this right here is h. H is +3. In both of these equations, you have this negative sign for both h and k. So you have to do that little opposite thing for both, which implies here that k is -1. So our vertex is 3, negative 1. Let's find p. So 12 is 4p, which means 3 is p. Since x is being squared, that tells me it's either up or down. And since p is positive, we're going to open up. So our vertex is 3, negative 1. Just like before, we're going to count using p to find the focus in the directrix. Since we're going to open up, I want you to visualize it opening up. And I'm going to count up 3. And this is going to be my focus. This is going to be my vertex. And down 3. And there's my directrix, which is the equation y equals negative 4. My focus is 3, 2. Now these are fairly easy numbers to work with, but just remember these equations, oh by the way there's supposed to be a comma here, these equations will help you find it in trickier situations, like if there's square roots involved, as I think some of the homework does have that. Okay, so then we use the focal width and call it a day on this question. So our focal width is 12, so we're going to count left and right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And remember, you count left to right from the focus. Do. A little messy, but it's there. All right, in this one, h is right here. It's negative 1. Actually, I was using red. And k is over here. It's 2. P is negative 8 divided by 4, which is negative 2. And this is going to open. If you look right here, the y being squared is going to be left or right, and this is negative, which tells me this is going to be left. Okay, so our vertex is negative 1, 2. Let me switch colors because it's a little easier to see. And our direction is left, and it's going to count 2. Count 2, count 2. Our focal width is 8, so we're going to go up 1, 2, 3, 4 from the focus, down 1, 2, 3, 4 from the focus. There she is. Okay. Find the equation of a parabola that has a vertex of 2, negative 3, and a directrix of x equals 5. All right, first thing we do is sketch a real quick graph. So 2, negative 3 is right here. So this is a vertex. Directrix of x equals 5. X equals implies that it's vertical, and it goes through 5 here. This is our directrix. That tells me a lot of information. It tells me everything I really need to know. I know it opens to the left, some way like this. I already know h and k. Here's h. Here's k. The only other thing I need to know is what's p. And that's actually pretty easy to find from the graph. It's this distance right here. That is, well, at least the absolute value of p is that, which you can count as 1, 2, 3. So the absolute value of p is 3, but I can see that it opens left, so that tells me that p is actually negative. All right, so the equation that opens left is our second one here, this one. So y minus k, which is negative 3, 4 times negative 3, which is our p, negative 12, x minus h, which is 2. And our last equation. Find the equation of a parabola that has a vertex of negative 3, 3, opens downward, and has a focal width of 20. So I have h and k. I know it opens down, so that gives me that I'm using this equation with the x being squared. It also tells me that P is less than 0 because it's opening down. So let's see, x minus h, which would be x plus 3, y minus k. And here, P, well, the focal width is 20. This is the absolute value for P. Since I know it's negative, P would have to be negative 5. So when I plug it in, there'll be a negative 20 there.